Hello students, how are you? I hope you are doing well. This time I have picked around three questions from the morning shift of 24th January 2023. The questions are basically have been taken from modern physics. Okay, so let us discuss question one by one. So the first question is a modulating signal is a square wave as shown in the figure. If the carrier wave is given as this much, then the modulation index is. See students, this question is of course very simple, extremely simple. It is just based on the basic concept. Now I would like to tell you that there are few other names given to modulation index. Okay, generally denoted by mu. Uh, in certain books, it is written as modulating factor. Modulating factor. In certain books, it's also written as depth of modulation. Depth of modulation. So all the three mean one and same. And in simple terms, see, we know the amplitude of the carrier wave. We also know the amplitude of the modulating wave. So it is given as amplitude of the modulating wave upon amplitude of the carrier wave. Basic definition. So what is the amplitude of modulating wave? It is exactly 1. Whereas that of 1 volt of course. Whereas that of carrier wave is 2 volt. So basically it is half. I hope that is clear. As simple as that. Let us move to the next question. The next question is an assertion reason kind of a question, as you can see. Assertion reads, photodiodes are preferably operated in reverse bias condition for light intensity measurement. This is actually true. Again, this is based on fundamental thing because as we know that photodiodes, the name itself indicates that it operates based on the light and it basically detects the intensity of light. More the intensity of light, more will be the current through the photodiode. Now, the thing is that in the forward bias, current is more, whereas in the reverse bias, current is less. So, when light keeps changing, the incident light keeps changing, then the corresponding change in current will be more during reverse bias because in the reverse bias current is already weak. So a small change in current will result in a more fractional change in current. Remember, it is a fractional change in current which is important and that is detected by it, not the total change in current. So since the current in the reverse bias is less, very less of the order of microampere, so the fractional change will be more if it is operated in the reverse bias. So that is the main reason that it is operated in the reverse bias. So assertion A is correct. Coming to reason, the current in the forward bias is more than the current in the reverse bias for a PN junction. Of course, reason is correct, but as you can see, that the real explanation comes out from that fractional change concept. Okay, and that is not being mentioned here. That the current in the forward bias is more than the current in the reverse bias. That's what it is given, but it is not the correct explanation. So, correct option should be this. Both A and R are true, but R is not the correct explanation. Okay, so second option is the correct answer. Let us move to the next question. Question number 3. You can see, consider the following radioactive decay process. The mass number and atomic number of A6 are respectively given by. So we have to find the mass number and the atomic number of the end product. End product is A6 as you can see. So straight away we will apply the shortcut. Okay, instead of going, one method is to go step by step. As you can see, A results in A1 and then A1 becomes A2, A2 becomes A3 and so on. That is one way. Each time the intermediate product you can go on writing the mass number and atomic number depending on whether the decay is alpha or beta or gamma. But that will be a long process, I guess. Let us see the total number of alpha particles, beta particles, and gamma particles I'm going to count. So as you can see here, there are total 2 alpha particles. Okay. So based on that, the mass number will reduce by 2 into 4. As you know, corresponding to the decay of each alpha particle. Remember what is alpha particle? Alpha particle is nothing but, you can say, helium nucleus. Helium nucleus. So the mass number decreases by 4 corresponding to each alpha decay. So altogether there are 2 alpha decays. So it will deduct by 8. So the new mass number will be 210. Then the atomic number will reduce by 2 corresponding to each alpha decay. So the atomic number will reduce by reduce by 2 into 2, that is 4. Alright. Then you can see there are few gamma decay also. As you know, gamma decay is basically the release of energy. Okay, just as you know, uh, there are different energy levels corresponding to different states of atom. Similarly, nucleus also can exist in different energy levels. So when the nucleus is in the excited energy level and it comes down to its original energy level, so it releases the excess energy in the form of gamma ray photon or quantum, you can call it. So as such, there is no change in mass number or atomic number, so no need to consider the gamma decay. Now coming to the beta decay, there is a negative beta decay and there is a positive beta decay. Normal beta decay is assumed to be a negative beta decay. In a negative beta decay, only the atomic number increases by 1, whereas in a positive beta decay the atomic number will decrease by 1, and there is no change in the mass numbers whatsoever. So that means altogether there is no change in further change in mass number or atomic number, because a minus beta decay would have increased the atomic number by 1, but at the same time a positive beta decay would have decreased the atomic number by 1, so resulting in no net change. So these are the final values. So correct option is 3. So that's all for today. Thank you so much, and I hope you are enjoying the way I teach. So please subscribe to my channel and also hit the like button. Kindly share with your friends and relatives. Thank you.